everybody, this is my video on how processors work. Last video we talked about Neumann's architecture, the 4 things you need to have a computer, and then a few other things that you also kind of need but more connect those components. So this video and the next 3 videos, we'll go through this piece by piece. We'll go through those 4 things. If you were in class, obviously you don't need to watch this video. This is just for those who couldn't make it. And this is the hardest one because we're going to talk about processors. Processors are actually the things in your computer doing the work. They're actually tiny little chips. It's remarkable how tiny they are, microscopic some of them, but they are doing all the work. They're actually what is allowing the computer to calculate the information. Everything that happens in your computer is calculations. It stores data and it calculates data and it uses that data to calculate more data, really, or either output it to you. So how processors work is by transistors. In my last video, we talked about transistors. Transistors are nothing but a switch. They're basically a light switch. If the switch is on, power is coming through, and that means on. And if they're off, then power isn't getting through, that means off. And you could do all kinds of cool things with that formulation. You could do all kinds of math, and you could do all kinds of ons and offs and things like that. You can store data that way, which is crazy, which we're going to get to later in this video. First, though, there is a YouTube video in the class material you really need to watch. He explains transistors and how they work a lot better than I can, so I'm just going to let you watch that video. But this is explaining upon how those transistors can build and be connected together to make the processor do what it does. So first is what's called basic gates. These are actually called truth gates, and all they are is 2 transistors put together. By the way, there's also a worksheet you have to do this week. If you're in the advanced class, you have to do it. If you're in the beginning class, don't worry about it. But there's a worksheet you have to do, which we'll talk more through all how this works too and put it down. But basically, there are 3 different ways to connect transistors together to make what's now called gates. So gates are the next building block of a transistor, and transistor is one switch on or off. A basic gate is 2 switches, but they're connected. So there's 3 of them. The first one is your AND gate. In an AND gate, if both transistors are on, they're wired together so that power comes here, and the output is on. So, but both of them have to be on. The AND gates are used to add. If you're wanting to do simple addition in a computer, your AND gates are used to add things together. And so an AND gate is if you have 2 switches, and if both are flipped on, then power gets through, and the gate is now considered on as well. If one switch is on and one is off, then it's off. The gate is off. Power doesn't get through. If this one's off and this one's on, power doesn't get through. If they're both off, obviously there's no power anywhere to come from. So that's your AND gate. Then there's an OR gate. That means one or the other has to be on. So they are wired together in such a way that if they're both off, then obviously power isn't getting through. But if one is on and one is off, they're wired together in such a way that power gets through and the gate is considered on. If they're both on, power gets through because all you need is one to be on. So if they're both on, power gets through. If one's on, one's off, power gets through. If this one's off and this one's on, power gets through. But if they're both off, obviously no power. So that's the OR gate. Then you have the NOT gate. The NOT gate is actually a very simple sort of gate. There's actually light switches that work this way. And that is if power's coming through, then the NOT gate cuts the power. So your NOT is actually just one transistor. It's the only gate that consists of one switch or one transistor. And so in a NOT gate, if power is coming through, it cuts it off. But if there's no power, then it flips on and lets power through. So those are your 3 basic gates. The AND and the OR are 2 transistors each. The NOT is just one transistor, but it's negated. If it's on, it's off. If it's off, it's on. So then you can use those to build 3 more gates. Build 3, we call them more basic gates. They're not really basic because they're a little bit more complicated than your basic gates. So I just call them more basic gates. But they are just as basic for your thinking and your logic as the first 3 gates. And so what these do is they add a third transistor. So a third transistor then allows the computer to do a few more things. The first of that is what's called a NAND gate, N-A-N-D, and it adds a NOT gate to an AND gate. So in the AND gate, you have 2 transistors. Then you add a NOT gate so that whatever the output would have been, then the NOT gate negates that. It takes zeros and turns them into ones, ons into offs, and offs into ons, or ones into zeros. And so you have 3 transistors, and the NAND negates that. So when you draw that out, a NAND gate looks the exact opposite of an AND gate. So if you can figure out an AND gate, you could get a NAND gate, because if it's 0 here, you're just 1 over here. And so in a NAND gate, if you're off and off, then you're actually on. And if you're off and on, then you're actually off. Whereas, anyway, it's the reverse. So it gets kind of complicated without a piece of paper in front of you. So then you have a NOR gate, which works the same way, but with an OR gate. An OR gate takes 2 transistors and adds that third NOT gate. And now it's the exact opposite of an OR gate. So in an OR gate, only one had to be on. So if this one was off and this one was on, an OR gate is on. But if I add a NOT, then an on becomes an off. And so a NOT gate negates it, and it reverses the outcome. So if you can figure out an OR gate, a NOR gate is really easy. You just do the opposite. If it's 0 here, it's 1 here. If it's 1 here, it's 0 here, right? Then you have another type of gate that's a little bit more complicated. It's called an exclusive OR. So in an OR gate, if you only had to have one that was on. And if both were on, then it was still on. In a XOR gate, XOR, if both are on, then it's off. But if one is on and one is off, then it's on. If this one's off and this one's on, then it's on. But if they're both off, obviously no power is going to get through. There's off. There's no power coming from anywhere. So those are the 6 basic gates. As I said, look at the worksheet. You know, you can rewind this and watch this again. Look at the worksheet, though, and that'll help you go through it. If you're in class with me, we go through the worksheet together in class. We'll probably do that tomorrow, whenever tomorrow is for you when you're watching this. But then we can actually build on those basic gates to make some really complex circuits that allow a processor to do 4 very important things. And so those are just basic gates. But then we combine them all together and put them all together and wire them together in such a way. And now, so with the basic gates, we're talking 2 to 3 transistors each. The complex circuits, we might be talking hundreds, if not millions of these types of circuits, depending on how big your processor is and how fast your processor is. But we can combine those all together to do what a processor does. So these are the 4 things a processor actually does, but they're really complex. The first thing is it adds and subtracts. I already mentioned that it uses AND gates to do that, to add and subtract. And so we call that the adder circuit, meaning it's a bunch of AND gates wired together so that you can add. And so it's a really complicated, sophisticated thing. You can find YouTube videos on it if you want to learn more, or take a hardware class. This is just an introductory class. So that's your first thing a processor does, is it adds a bunch of stuff together. There's an adder portion of your processor. Then there is a shifter portion of your processor, which is how you multiply and divide. What a shifter does is it shifts ones and zeros over and then adds a 1 to the end digit. The binary math on this is really interesting. I don't have time in this video to go over it. We may have time to go over it in class. But basically, by shifting your transistors over and adding 1, it allows your processor to multiply. Because in binary, anytime you multiply 2 numbers together, you're shifting the ones and zeros over, which is fascinating. So as I said, you can watch videos on that. So a shifter is what allows a processor to multiply and divide. An adder is just a bunch of AND gates that allows you to add and subtract. A shifter shifts data over. It says, oh, if this one is on, then we're going to shift that on over one. And if this one was on, that one's going to get shifted here. And we're going to add something to the end of it. When we go over how to do binary conversions from decimal, you'll see that a little bit more, but fascinating thing. So you have an adder and a shifter. Add and subtracts, shifter multiplies and divides. Very important. You have two more very important things that happen. One is a decoder circuit. Decoder circuits are very complicated, and there's several different types of them. But basically what a decoder circuit does is it allows your computer to decode information. Now, if you look at your computer screen right now, you're seeing, if you're watching me, you're seeing all kinds of colors. You're not seeing math. You're not seeing numbers. Well, a decoder circuit takes a binary value, and we're going to talk about this later too. It takes a binary value and it assigns it to a color, so it knows to turn this pixel to this color. So right now my shirt's red. Hopefully it's red on your screen. So what's happening is that's going through a decoder circuit right now, and it's saying, move that pixel to red. Move this pixel up here to white, the wall behind me, right? Who knows what it's doing with my hair. And so decoder circuits do that. Decoders turn numbers into text. Sorry, I choked on something. Decoders turn number into text. That's another important thing that they do. So decoders are very sophisticated. We're not going to go into the logic of all that, but decoders are basically what translates an input into another type of output. And it's very fascinating, and there's different ones for different things. Then the fourth thing your processor does is it stores memory, but we call those flip-flop circuits. And so flip-flop circuits mean they really are two circuits wired together, an AND and a NAND. And no matter what input's coming in over here, the output, depending on which circuit is on top, stays the same. And so, because it's negated. So a flip-flop takes an AND and a NAND gate, and it flips it so that if you want the output of a 1, it will always be a 1. And if you want the output of a 0, if you flip it the other way, the output will always be a 0 no matter what happens, no matter what's coming in. If power isn't coming in and the NAND is on the bottom, then power isn't getting out. If power is coming in and the NAND is on the bottom, it's still off. So that's how you build what's called RAM, which we're going to talk about in a future video. And so flip-flop is the thing you need to know at this very basic level of computers, is flip-flop is what allows a processor to store memory, particularly RAM. ROM is another type of memory, but flip-flops use an AND and an AND gate together, and it flips them depending on whether you want a 1 or a 0 outcoming. And so the output will always stay the same no matter if something's coming in or something's not coming in. And so those are the 4 complex circuits built on those 6 basic circuits, so that your computer can do everything that it's doing right now as it's just playing this video. It's using all those circuits to play this video for you, which is quite fascinating. So check out the worksheet if you didn't get all that. Definitely check out the YouTube video on transistors, and we'll see you next time to talk a little bit about buses or memory if you're watching these out of order or something else. So stay tuned.